Then some questions we are, let me go with this. So I'm keep on telling you that we can answer the gate questions with the minimal valid input string. I'll give you a proof of it, right? See, this was asked in gate 2007 and the common data question. So the first question is, you'll be given a automata and a regular expression, and they asked, so what is the equivalent regular expression for this automata? And the second question is, how many minimum number of states in this automata? So let me go with this. So the language accepted by this automata given by the regular expression they have given. So I'm keep on telling you, and most of the questions in gate can be answered with the minimal valid input string. Let me go with this. Then take it, L equivalent to, so what is the minimal valid input string accepted by this automata means, here the starting state is Q0. From Q0, what is the minimum string to be accepted means A. So Q1 is final state A. And see, we'll go with this. I'm not even taking the second string. I'll go with this regular expression. And what is the minimum string from this first A means, make all the star value equivalent to 0. So epsilon, 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 epsilon. If the star means you can nullify it. So this become epsilon, this become epsilon, epsilon, epsilon. And what is the minimum string I can generate from here means triple A. So from this regular expression I can generate the triple A, but from the language I can generate the A. So this is not the answer. Directly you can tell it. Then same way, what is the minimum string from this A plus B whole star means, it is nothing but the epsilon, because when you star equivalent to 0, the complete term become nullified. So answer is not even B. And what is the minimum string I can generate from here? This can be epsilon and this can be epsilon. So what is the minimum string I can generate here? A. And same A here. I'm not saying that C is the answer, because my intention is not to select the correct answer. My intention is to eliminate the wrong answers. Then you go with this D. So what is the minimum string I can generate means, you can take this all star value equivalent 0. Then you will get the minimum string double A. But in our language it is A. So answer is not the D. So what is the correct answer here? C. So that's the beauty of eliminating the wrong answers. And that's what I told you, even the minimal valid input strings. Then there is a second question. There is a first question, sorry. And what is the second question they have given? How many minimum number of states in it? So the options were like this: A1, so B2 and C3 and D4. Options are given like this. So, but nowadays you can get the numerical answer type of question. You may not be given the options, but in 2007 they have given the options. Then how to identify this? Let me go with this. See, what is a minimal valid input string means A. The length of the minimal valid input string is N, means the automata at least contain N plus 1. I'm not saying that minimum, but at least it would be N plus 1. The answer may be N plus 2, N plus 3, N plus 4 or so on. I don't know exactly for the language, means for all the languages. For a particular language, if the length of the minimal valid input string is N, means at least it has to contain N plus 1 states. So here it is 1, means answer must not be 1, because at least you have to take the 2 states. I don't know for this how many we are going to get it, because we have not done any process, but I can eliminate some wrong answers. Then same way, here we are having 4 states. The minimal finite automata may have 4 or less than 4, that I don't know. Then how we have to do it means, when you can say that an automata is minimal, it must not contain the unreachable states, equal states, and it should contain 0 or 1 dead state. Let me go with this. From Q0 I can reach the Q1, from Q0 I can reach the Q2, but from Q0 I cannot reach the Q3. So here Q3 is the unreachable state. So in our minimal automata, you are not going to even have the unreachable states. So answer is not even D. Right. Then let me go with this. We are having only 3 states left: Q0, Q1, Q2. So no unreachable state, no equal states. So either equal means any 2 states are equal, or we have to check it. Let me go with this. And how many pairs you are going to get here? So Q0, Q1 is 1 pair, and another pair is Q0, Q2 is another pair. Then the final one, Q1 and Q2. Right. We have to verify which are equal here. A pair of non-final state and a final state never be equal. Right. Final state. And same way, Q0 is non-final and Q2 is final. So never be equal. And Q1 is final, Q2 is final, then there may be a chance of equal. Then you just prove it whether those two are equal or not. Then how can we do this, whether those two are equal or not? You can write the behavior of it. Let me go with this. So how to find the minimal automata? Then you can take in this way. First divide them into non-final group and final group. So Q1, Q2, write down the behavior. This is a non-final group and this is a final group. So Q1A where we are going, Q1A we are going to, Q2 means which group it is, final group. And Q1B where we are going to Q1 means which group, final group. And Q2A where we are going, same again it is Q1 is nothing but final group, and Q2B we are going to, Q2 is nothing but the final. So these two are having the same behavior. So we can combine these two states. Then you are going to get only two states. One is Q0 and another one is final state, that is Q1, Q2. Then Q0B we are going to the same state, and Q1A we are going to the Q0A. Then you can write it same. How many states we are going to have here? 2 states. So answer is 2 states.